Hello, hello, and welcome to Python for Scientific Computing edition year 2025. I am very happy that we managed to do again this hopefully useful course. And we have many people online that are watching us and interacting with us, but we have, of course, a few people here in the room with me. How are you, everyone here? So, do you wanna briefly introduce yourself? I see my list first, Heman.
Yeah, hi, this is Himan. I'm working at the University of Iceland in Reykjavik, and it's really nice to have you here.
Heman will be teaching in the morning with Diana about kind of the introduction on how to work with Python, specifically for scientific computing, for data analysis. So, Diana, do you want to mention something about yourself?
Yeah, hi everyone. I'm Diana Yashan. I'm working at Uppsala University and also for NICE. Very happy to be part of this great course that Aalto University is leading, and I hope you'll enjoy it. Thank you.
Thank you so much. And since Aalto was mentioned, I'm actually from Aalto University, and we also have another Aaltonian here. Susa, do you want to say something about yourself?
Hi everyone. Yeah, I'm Susa. I'll be teaching. Well, the first time you'll see me is when we're teaching NumPy in about an hour, I think. But you'll be seeing me, I think, throughout the course this time around. Um, I'm an RSE at Arto and trying to make it, well, trying to teach as much as I know about computing to and as many people as possible.
Yes. So the page that we are sharing right now is the so-called notes document. You should all have received it in the email. And the idea of the notes document, I will explain it soon at the clock. The idea is that we can all edit this document. But as you can understand, since there are almost 500 people watching this, if you don't need to write anything, you can stay into this view mode. But in general, since we're talking about languages, many of us, we're now using English, but I believe nobody of us here is mother tongue English. So I'm Italian myself, and the rest of us here is from other countries. So if we think of this metaphor in programming languages, and if the first language you learn is your mother tongue programming language, what did you start with, Diana? What was your first programming language?
I first learned C, and then a little bit after that it was Fortran. Took a couple of years to start getting into Python as well, as it became more popular. Yeah.
So now Python is the language that you speak daily, basically.
Yeah, that's true.
Yeah.
I do speak the other one still, but yes, Python is uh, very common
Yeah,
in the day-to-day work.
it was a little bit the same for me that I also started with C and C++, and then which was maybe painful is not the right word, but let's say not as fun as other languages. And then I had a detour with MATLAB actually for many years. I've just been using MATLAB, but then in recent years, Python and R are my are the languages that I speak today, apart from Finnish, that I'm still learning. What about you, Heman? What was your mother tongue in programming language?
I started actually similar, I started with C, C++ mostly, and then shifted to Fortran because most of
Okay,
the community is focusing on Fortran at that time. And then more recently, Python, this kind of thing. So yeah, it's like a
interesting.
kind of a mixture. When a new language comes and becoming popular, I started diving into it.
Interesting. So it looks like that C is winning as the. What about you, Susa? What was your
Well,
first programming language?
so the I would argue that actual first programming language isn't what would be my programming mother tongue, because the first thing I did programming in was BASIC. And then I learned Dr. Scheme, which is a Lisp dialect, if anyone knows what that is. It's basically a scripting language. It's how complicated, and I hate it. So no, and I would call my actual native programming language would be Java.
Oh,
Because that's what we used in when I started studying computer science the second time. Um, but then I've been doing lots and lots and lots of other programming languages. I did MATLAB for quite a while. I did Python a lot. I do R, though I don't like it. But I've also done things in C. There's a dialect of C basically called the Small Devices C compiler. Like
I
that's
didn't know that.
so yeah, my programming language experience is very, very broad.
Yeah, excellent. So as you can see, for those watching us in the streaming, you might learn Python today, you might switch to something else in 1 year or 10 years. In the end, what matters is that you're able, to transfer your ideas and wishes from your brain to a device that is then going to do what you ask it to do. But basically, yes. So we have still a few seconds before we officially start the course at the 10 o'clock finish time, 9 o'clock Central European time. Let me just have a look if, so right now in this notes document, there's 152 people using it. Let's hope we don't crash the server. Just to give you an idea, a Google Doc would limit 100 edits, 100 concurrent users. So we are now beating Google Docs with the server, but hopefully everything will be fine. So let's just start. Hello everyone and welcome to Python for Scientific Computing 2025. I'm Enrico Glerian and I'm the organizer of this course, along with a multitude of people behind the scenes who are taking care of the streaming and installations and course materials and so on. In this course, we are basically using two main tools, which is the TwitchTV stream that you're watching right now, and this notes document that we are seeing in the stream. Here you can see that we recommend for those at least to just have a laptop screen, that you can arrange your windows so that the web browser with the Twitch TV stream takes, let's say, the left hand side of your laptop screen, and then you can have the Python window and then another browser window, for example, with this document where you can ask questions. Of course, if you have multiple screens, you can rearrange the screens as you wish, but this is why basically we do this vertical screen sharing so that those with a laptop have a little bit of free space around it. So what you see right now is this so-called notes document, and I will ask Iman now, if you scroll up into this document, there should be a pencil. Sometimes it's on the, yeah, there it is. So if you click the pencil, this document turns into an editor. And so the first block here, we basically would like you that you don't edit it because it's useful. There are the links that we need throughout the course. But in the bottom, there are some icebreakers so that people can write, and I can see that people are already writing where they're from. And I wrote a couple of silly questions. How much have you used Python before? And how much have you used Jupyter before? And where do you store your files? So it's interesting to see, how diverse we are. Some people are experienced Python users. Some people might be, the first day today that they started Jupyter and will edit. And I think one powerful thing of this course is that we try to give a little bit of everything. There's some take-home messages and learning outcomes for the truly beginner, but there's also insights for those who have been working with Python for many years. Then when you don't need to edit this document, because as I mentioned earlier, there's many people editing, it's good to switch to the view mode. So like it's doing now by clicking on the eye. And now in the very top there is this program link. Would you mind clicking it? So here, if we scroll down to the schedule, we see the schedule for today and the 2 following days. And so this morning, we will start with the basics of Python and specifically a little bit of Jupyter. We will not really go into the Python syntax. It's kind of learn by doing. So if you have syntax errors, the error messages hopefully are clear enough to correct you with the syntax. After we will have then a lunch break at around 12 Finnish time, so 11 Norwegian, Swedish time. And after that, we will talk about pandas, which is a framework for working with tabular data, and X-arrays, which kind of adds, how can I say, extra power to working with tabular data. And this will be our first day. I will not spoil the fun for the second and the third day, but if you could click on this intro bit that we have already started. So I already mentioned the course content, so we can scroll a bit more down. And so how to attend this course. Instead of using Zoom and having people in the Zoom window and basically, trying to avoid names, because what we really want is that we would like to record this workshop and publish the videos. And if people are on the Zoom and they want to ask questions, it becomes difficult with the practicalities. So by using TwitchTV, we can allow immediate recordings and immediate publishing of the recordings. And also people can just watch from wherever device they are without, need to be in Zoom. So the live stream is like watching TV, and some of you might be watching TV together with their colleagues in some rooms. Some of you might be at home. And then if you want, there's also the possibility to do exercises. But in general, you can just watch the stream and eventually ask questions. So when it comes to asking questions, this chat, the communication, we already gave you kind of a demo of how it works. And it's interesting to see that almost 200 of you are right now editing the document, which is great. And so the notes are very useful. And in the very bottom, we don't need to show the notes right now, but in the very bottom, I also included the questions that were sent earlier through the registration, so you can already see some answers there. Screen arrangements, I've already mentioned this, but here you get good, how can I say, screenshot of how it can look like on a laptop. Maybe something important that I should mention is that the Twitch TV tends to save bandwidth, which basically means that sometimes the stream might look pixelated and the sound might look robotic. And this is because Twitch TV is trying to use less internet bandwidth. So it's important that you set the source quality of the Twitch TV stream to source, so that basically you will never get pixelated images and robotic sounds. So what else? Where do you focus? Well, in general, if you are lost, and we are all lost once in a while, it's good to focus on the lecture, on what our instructors are saying, and just watch the stream. When there will be exercises, there will be clearly mentioned in the notes document what is the task that you need to do. If you're able to do it, it's great. If you are not able to do it because maybe the installation didn't go successfully, you can do it later. There's no pressure. Maybe we don't need to go through the list of what can go wrong, but in general, we use the notes document to communicate. So if the internet collapses, or which can happen. Last week there was just Cloudflare collapsed that blocked large part of the internet. So if something is extremely wrong, you will hear from us. And finally, of course, we follow the code of conduct of Code Refinery, which is our umbrella organization for all these trainings. So we just like people to be respectful and helpful, and we all come from multiple different countries with very different backgrounds. So there's no, best or worst of us. We are just all learners, including us who are here teaching. And so let's just enjoy these 3 days together. Final note, it is possible to get certificates, and in the web page of the course it clearly says how to obtain those. For those at Aalto University, there's a little bit special way of doing it, but you will receive an email from me. Otherwise, enjoy the course. It's 8 minutes past 10 in Finland. I think I've talked enough, and let's just start. So I pass the microphone to Diana and Hema, and see you later and enjoy the course.
Thank you, Enrico. So now we are going to continue with Jupyter, and Herman is going to, or is sharing the screen right now. I will just mention that if you've been using Jupyter for a while, then this is going to be a very easy lesson for you. So go to the notes document then and check the questions that we have added at the bottom of it and share your experience with it and the best practices. What would you like others to know about Jupyter? Pros and cons, favorite ideas that you may have. And also, if you do not want to do things in Jupyter for this workshop, that's perfectly fine. Use your favorite IDE or your favorite IDE with Jupyter notebooks, that's perfectly fine. But now we'll start with Jupyter. So Heman, I'm giving the word to you now.
Yeah, hi. Thanks, Diana and Enrico. So yeah, in the next 30 minutes, what we will be doing is mostly like going through the Jupyter, like basically try to focus on like what the Jupyter kernel looks like and what are the pros and cons of Jupyter. So the Jupyter, like basically it has you can build up a computational narrative using this Jupyter. It is a kind of a fun like of doing that. And maybe if you want to share the kernel with others, like it is also like a kind of very interactive way of doing it. So in the rest of the course, basically, if you're already familiar with the Jupyter, what you can do is like there are some exercises below. So if you scroll down a bit below, like you can see exercise like 1, 2, and 3. Like so, if you are already familiar with Jupyter, you can jump to exercise 3 and try to like edit the note. Basically, it's like collaborative notes where you can add your experiences. So otherwise, like just relax, like and then like follow the lecture today. Okay. So why Jupyter? Yeah. What is Jupyter like, and what are we going to use it for? Like basically, so Jupyter is mostly used for like teaching purpose, like or also like for doing data exploration and the kind of interactive work. Diana, could you share your experience with the Jupyter? Like,
Yeah, so the way I use Jupyter, actually I use either Jupyter Lab or I use it in VS Code with extensions for Jupyter notebooks. It's mostly for data visualization, or sometimes I just want to inspect different different data. I use it for teaching, and especially if I want to combine some code together with documentation. So if I want to show someone, okay, how does this script what does this script do and how you should use it, and then I would prefer to show that in a notebook. So early stages of development as well. And then once things get too long, then once the script gets too complex, then I will jump into scripts, and we are going to cover that later in the workshop as well.
Okay, great.
So yeah.
Yeah, so let's start Jupyter Lab. Okay, so in like you already might receive the installation instructions. Otherwise, like when you we when you're doing the exercises, you can follow the installation instructions. It is pretty easy to set up the Jupyter, and for the day one and the next coming days, you will be using the Jupyter for the Python for scientific computing. So I recommend you to like uh, in case if you haven't installed, try to follow the installation instructions. So there are different ways of installing. I choose a mini forge basically. Otherwise, you can also choose Anaconda or your favorite setup. So I will just copy these lines because I already installed it in my laptop. So I will switch here. So let's make scroll a bit. Okay. So just I'm copying these lines. So I'm just searching my mini force and then activating my Conda and then starting it, my Jupyter Lab. So just copy and paste, and it will basically then redirect you to the Jupyter kernel. Okay. So now I will hide this terminal for a while. Okay. So
then this way it starts in your default browser, basically.
yes, let me close this. Okay, when you start the kernel, so what you can see here is like a kind of a, you have the menu bar here on the top, file, edit, which is a typical menu bars you see in Doc or any of the other tools. And here you have like a kind of, if you are starting new, you can start a new launcher here, and it will open this uh, basically you can start a new Python notebook by clicking on this Python 3, or else in case if you are want to use other consoles and terminal, you can scroll down and see like you can use terminal and other things. So let's go back, and in case if you are already using it, you might see a multiple Python kernels. Since I was using a lot, so I have a bunch of other stuff. But if you are starting from scratch, you will only see a couple of them, like only this kernel. Okay.
So it's
Let me
nice to see Jupyter Lab actually picked up all the environments that you have installed on your computer.
Yeah, yeah, that's interesting. So then, okay, it's like so the first thing you will be doing is like first of all try to save the file. By default, when you open this Jupyter notebook, it will not save. So you have to save by going to the file, and actually you can right click here, and you can rename the notebook on and say okay, like a demo. Okay, and you can see here on this sidebar that the file name has been changed. Okay, so let's walk through like what are the different icons here. Like here you have a save button, and basically it's like this scissor is like if you want to cut the cell. Let's try to create some cells, and what you can do is like you can cut the cell or you can paste the cells. Okay, so these are different icons here. So, and then if you go here, you can find like Jupyter has two different cells, like cell types. One is a code cell and the other one is a markdown cell. So the markdown cell, if you change here, like this is the same thing what you are using when you're writing the collaborative notebooks. Okay. So for suppose you can use this is a heading for suppose. So this is the biggest heading you can find, like, and you can double click and edit basically that cell. For suppose this is a heading 2, like this. Okay, So, and in case if you want to change, like you can change the cell type, okay, from markdown to code or code to markdown, because accidentally sometimes you try when you create a cell, it will create by default the code cell, and you want to change it into markdown. You can do that one. So yeah, then
So this is, sorry, I
yeah,
just
go
want
ahead.
to say that it's great that you can either choose code or Markdown. Markdown is great if you want to document a certain part of your code, so that it's the documentation is close to the code snippet that you want to emphasize.
Nice. So let's do just a print command. Yeah, I am using a different Icelandic keyboard, so I need to find the right keys. So this is how you try to print, uh, use a print command. And what you can see is like by default, we have here, like if you scroll a bit, by default, it is a Python kernel. So, and when you execute this cell, it will print this print command. You can also like try to create like a list. Let's look at some code examples here. Okay, what you can see is like if you do this one, it will print all the numbers up to 3. Okay, 3 is excluded, so we see only 0, 1, and 2. Okay, so let's try some more examples. Like so, for suppose if you want to like some numbers from 0 to 3, what you can do is like oops, I think I missed one closing bracket. So yeah, now when you execute it, like you can see that it is you can do the summation up to 3. Okay, so you don't need to use a print command. You can actually like uh, for suppose I copy this cell from sum. Okay, and when you execute it, and the way you execute is like you can use a shift and enter. Okay, and yeah, then you can see like you can use the print command, or you can directly run the command you are using it. The reason we recommend using a print command is like, for suppose if I add here, like say instead of sum up to 3, let's say sum up to 5, what you see is like you can only see the second line which is executed. Okay, I mean you can only see the output of the second one. So in case if you want to see the outcome of the first one, you try to use the print command. Okay, so in that way, like you can see the both the outputs. So that's the kind of it. Yeah. So then, yeah, let's go to the magic commands. Susan, do you have any magic commands? Like, what is magic commands? Like, what is your favorite magic?
LS, I guess.
LS, nice.
Although you can
So,
do that in other ways as well, but yeah,
yeah.
I mean, one can also time it is a nice one as well. So what we show here, yeah, indeed,
So,
it's useful.
agree. Yeah, let's time it. Okay, so basically it's like when you are we call it a magic commands because it's like these are outside the Python commands. Okay, so for suppose if you are using a bash or anything, then you can use an inline commands, or it can be a multi-line commands. Okay, so here what we are looking is like when you type percentage ls, what you see is like all the files which are listed here. Okay, and you can also see on the onto your left whatever the files I have in that particular folder. And let's also look at the time it command. Okay, let's let me create a new cell, and I'm not sure whether the PWD works for everyone. Okay, since I was using Linux, it might be working for me. But in case if you're using Windows or some other operating system, some of the commands might not be native. So no need to worry about it. Okay. So yeah, Suzanne's favorite command is time it. So let's try the time it. Okay. Oops. I need to enter because it's a time it requires some input. Basically, what the time it does is like it tries to time the execution of that particular cell. Okay, so it runs multiple times and gives you like how much time did it spend to execute this. So here what we are doing is like we are just doing for up to range 100. Okay, trying to see like what is x square. Okay, and what you can see is like it runs for 100,000 loops, the same command like and then each loop is taking sorry 100 into 1000, and that is 100,000, and each loop is taking about 3.5 microseconds. Okay, so this you can use the collaborator notebook to write how much time does it send. It's the first exercise you're going to do later, first or second, I think. So then let's look at some more commands. Let's take a bash for suppose, and if I want to like change, let's see what I have here in. Uh, okay, so, yeah. So what I have, what I was doing here is like you can have multiple commands like ls, and you can change the path and see what is there already in the two parent directories before. Okay, so uh, and let's do one more thing. Let's create one more cells, and you can create more cells by pressing this plus button. So let's take another bash, and I was taking this commands from the notebook itself. Like I was just copying it from. If you go scroll down, you can see some of the uh, what we are doing is like we are copying these lines. Okay, let's copy this one, this bash, and try to execute it here. So yep. So this is all about cell magic and line magic. The cell magic starts with the two percentages, and the line magic starts with the 1%, and it is like a kind of uh, uh, what we have is like whether we want to apply it to the whole cell or one cell. Okay. So after this, so Susan, like you have, shall we go to the exercise then?
Yeah, I think that's a
Or
good
you have
idea.
any? Okay.
So just one comment that I mean, if some of these line magics don't work for you, don't worry about that. If you find them useful for your workflow, use them. Otherwise, I mean, you can ignore it. It's not something that you need to learn here or now. But we find them useful, so we thought we'd share them with you. But now I think it's time you try out these exercises 1 to 3. If you find number 1 too easy, then just skip and if you are experienced, try exercise 2, for example, for a larger number in the Fibonacci sequence, and try different ways. Maybe parallelize it if you really want to. So try out your best and time your little code. And then we come back in, let's say, how much time should we give them?
Maybe 15-20 minutes. I
Yeah.
don't know.
And
Okay.
then please write in the notes document when you are done, so that we know if it's a good time to get back. Otherwise, we say we are back here at let me see what.
Yeah.
So
Thanks. Back in 15 minutes.
in 15 minutes. Yeah.
Yeah. Bye. Hello, welcome back. So I hope you tried these exercises which are here in the break. Like basically, it's like so the first one is basically it's like let's walk through some of these exercises and okay, the first task is basically it's like in case if you haven't installed, like try to run some basic commands like opening a Python notebook and creating new cells and saving it. I hope you tried it. And then in the next exercise, it is mostly like uh, writing your own Fibonacci numbers. Like basically it's like a Fibonacci sequence and printing out the Fibonacci numbers and timing it out. So let me take a quick look. I hope I see that a lot of people tried the exercise 1 and 2. So yes. So yeah, this is like basically it's like a you can see the solution also in case if you want to compare the solutions, like it is also available on the course page. Like so here, like basically what we are doing is like we are printing the Fibonacci numbers, which is the sum of the previous two numbers, and later timing it out for the first 10 numbers. So you can see that it took about 238 nanoseconds for running this range 10. And the next task is like increasing the numbers from 10 to like say bigger, I think it's about million or so, and try to like time it out. So, and then you can actually speed up the your algorithms. There are different ways of speeding up your algorithms. This is one way, but you might come across like your own favorite way. So try to like write it in the shared collaborative notebooks, how much time you got. Like it's interesting to see like people might have different approaches for the same problem. So then yeah, there is one thing which is like when now so far you have created the cells, you know how to write like execute the cells like and you know how to also add a markdown, okay, and then like write your own notes, narrative notes for this markdown, okay. So then on the top here, like basically it's like what you can do is like you can restart the kernels and basically clear all the outputs in case if you want to share these files to your friends or anyone, then you can choose this like option. So there is a yeah, and when you are executing the cells, it matters like how you are executing. Like for suppose in case in the previous couple of minutes back, we looked at this how to print this uh, the for loop basically, and this is the first cell which I executed, and then later I tried to create another cell on the top, which is now I is equal to 3. Okay, if I execute this cell now, the number will change from 20 to the new number 23, which you can see in the square brackets. This square brackets tells you that the order of execution, like so it really matters. Like and now if you say that print I, what happens is like it takes the number 3 instead of 2. Okay, if you go by sequence order, okay, from top to bottom. So it really like you should be very careful when you are creating the Jupyter like notebooks. Try to keep it in the order, and yeah. So that's about these exercises.
So always
Mhm.
always restart the kernel, run all cells before you share a notebook with other people.
Yeah, and
Are
let's
there any
restart.
reasons when one should not restart the kernel?
Sometimes it really depends. For suppose if you have it to, I see most of the people, if they are in the machine learning or deep learning, like they want to train their models. So sometimes the training might take a longer time. So in that case, it's better avoid like you can save a lot of time in case not restarting the kernels unless it is needed, you know.
So
So it's
restarting the kernel actually means removing
yes.
all variables from memory,
Mhm.
all initialization of functions, and then basically all data which has not been saved to a file is lost.
Yes.
So if you have a time-consuming notebook, then you might think twice before restarting.
Or else it would be nice to save the files, like, and then if there is a possibility of reopening and loading the weights, it would be also another way of just
Yeah,
in
that's
case if you
great
want to restart.
practice.
Yeah. So, okay. Then that's all about the exercises. And let's go back. Why Jupyter? Yeah, why do you want to use Jupyter? Like, what is the pros and cons of using Jupyter? Susan, like, uh, yeah, what?
Yeah, so I mean, I think Jupyter is really great for interactive work and for notebooks which are not that complex. I think once you get the workflow settled, then what I typically like to do is to transform it into a Python script and run that as we run that in production mode. And also what I dislike a little bit about Jupyter is that it's not so trivial to version control. I mean, as we do mention, there is the nbdime package which can help you with that, but I think it is much easier to version control Python scripts instead. So that's a little bit of a bottleneck. But yeah.
For me, it's like I use Jupyter like for teaching mostly. It's like it's really nice for suppose in this course. Okay, so a lot of people might be using a different systems like a Windows or Linux or something. Okay, once you confine them to particular environment, it's nice to share like teaching the Jupyter. Like what you will be seeing later is like Python for scientific computing, like a different ways, NumPy and other things. So it's like it's nice when you are sharing the notebooks. Okay, I also use for mostly for yeah most of my teaching. It's nice for the students to try basically. Then why not Jupyter? Okay, I mean, so it's always good to know like what is good and bad about any tools we use. Okay. So Susan, like what in case if you want to find another alternative or like yeah, what is your preference like?
Yeah, then I think yeah, I'll go to scripting after a while. So
Mhm.
and especially, I mean, if I don't want to, if I, as I said, if I have my, if I already know what I want to achieve with my workflow, everything is set up, then I would just run that as a script. Then I don't have to babysit that notebook all the time, and it can just run 4 hours or whatever it needs, and then I can check the results later. But for visualizing data, for doing things interactively, tweaking maybe a notebook that I got from a friend and using it in my own data, that's Jupyter is great for that.
Yeah, I completely agree. Like, so what do we have then?
I think
Shall we?
it's actually the end of our lesson. I would just
Yeah,
like to say that please do check the notes document and see how other people have been using Jupyter and other IDs that they prefer. And thank you for those of you that have been sharing your experiences with us. And we will post these Q&As on the workshop page so you can refer to them later.
yeah. Thanks.
Okay.
Thank you all. Yeah.
Thank you all, and then we'll now take a break until 10 o'clock if you're in Sweden or 11 in Finland. So take some time to stretch your legs and get something to drink, and we'll see you back in 9 minutes.
Yeah. Bye.
Right, and welcome back from the break to the lesson about NumPy. I've got Marijn van Vliet here with me, who's a real NumPy wizard actually. So I'll well, I'll ask stupid questions, and hopefully Marijn will be able to answer them all.
I will do my best. Yeah, thank you, Susa, and welcome everyone to NumPy. It's the first scientific package we're gonna discuss during this course, and we're gonna discuss many of them. And we're gonna start with NumPy because it's the OG, it's the foundation package. It's the thing that makes scientific computing possible with Python. It is super useful just by itself to learn about and to know. But it's also the basis of many of the other packages we will talk about today and tomorrow, like pandas and X-ray and things like that. They're built on top of NumPy. So, well, what is NumPy, right? NumPy allows us to work with data, with a huge grid of numbers. If we are doing astrophysics and we are looking at the stars, in the end, it's going to be a grid of data. If we're looking at brains and neuroscience, our brain signal is going to be huge amounts of numbers. Temperatures across the globe, they're all numbers. And that's what NumPy is going to do. And the main data structure for that is an array. So we should first talk about arrays. So you might think if we want to work with huge amount of numbers, we have something for that. We have Python lists. And Python has a list, and these lists are very useful and they're very flexible because you can put anything you want in a list. We can have lists with integer values, floating point numbers, strings. We can put lists insides of other lists and objects. That makes them very flexible. That's very good. But it also makes them very slow. So if we put all of our numbers in a Python list and we want to do something with them, say we want to add 1 to every element in the list, then a normal Python list, we need to go element by element because, well, it could be anything. So for each element, we have to check, what does adding 1 to this thing actually mean? If we have a number and a string, they mean different things. So we have to go step by step. And it just goes slow. This is not good for science. We want fast operations. We want to be able to do the same operation on a huge amount of data all at once. And that's where an array comes in. So to demonstrate this, this claim about speed, maybe we can showcase this a little bit, Susa. So let's create just a Python list with a bunch of numbers and then do something to those numbers.
Okay, well, maybe we've got an example here in our, so I'll just maybe copy this and then go to my Jupyter. I'll just make a new cell and paste this in here.
So what does this do, this code?
It does nothing nothing obvious because it doesn't print anything. But I guess we could say print B or something, right?
Oh, we could. Oh, that's a lot of numbers. Okay, yeah.
It's a long number.
We created 2 Python lists. Okay, maybe get rid of this first. But okay, so we have A and B, and we have a list of the numbers 0 to 10,000 minus 1, and and a bunch of zeros. Okay, let's do something to this list. So, for example, let's can we square every number? So
I guess
we have A and raise all those numbers to the power of 2. Let's square them.
Okay, so we've got A, and we want to do I don't know.
And maybe assign them to B. So we now have a list B, which is all zeros at the moment.
Okay.
but it's the same size as list A.
Yes.
So let's make it so that we loop over A, over all the elements, we square them, and write them to B. So, yeah.
B. Do we want to append them or?
Just create an for I in range length of A. Just create an I iterator.
Okay.
Or just copy it from the materials.
I guess I could copy.
Or you can. But this already demonstrate. Like, okay, so we want to do something. We want to square the numbers. Look how long it takes us already to do this. Wait, we have to write a for loop.
Yes.
How do we want to do it? Do we want to like enumerate over them? Do we want to make an integer index? And I mean, this is not that bad in terms of how it works in Python. I mean, it's still quite readable, but it could be better, right?
Yeah. I mean, if I do this now, it runs, right?
It runs. Okay, yeah, it runs pretty quick. So this is how you do it, and hopefully now B contains like the same as A, but everything is squared.
Well,
You can just print B or just put B in there. And do we have it? We do. Okay.
looks...
Whoa, the numbers go very, very big. Okay, but Python is good. That one is good with Python. Hey, but now let's do it in NumPy. So that was a little bit painful.
Do we maybe want to know how long it takes, because we have this time it magic, right?
Yeah. Oh,
so
but to be fair, let's add it to cell 10 and not this time, because this is the setup.
True.
If you want to be really fair about it, you should only time the for loop that does the squaring of the values.
True. Time it like this, right?
Yeah.
Okay.
Yeah, we can have that.
Let's run that.
I mean, it looked pretty fast. Well, it's only 10,000, but Python is not that slow. So it takes about, what is it, 9, almost 10 milliseconds. Not that bad. We have $10,000. But let's see how this works. How this would work in NumPy. So the big difference in NumPy is that we're not going to create a Python list. We're going to create a NumPy array. So can you now create a NumPy array?
Hang on, there's like a million ways to create a NumPy array, aren't there? Like we had a lot of them.
That's true. There are a million ways. Yeah. Hey, and the first way is actually if we have a Python list with the numbers that we want.
Yeah.
And if we want to make a NumPy array with that, that's like the first way to do it. The first way to create a NumPy array is that if you have a Python list, you can change it into a NumPy array. Maybe you can show that works. So you can do np.array, and then as first argument, you give it the Python list. That will create a NumPy array for you with the same contents as that Python list. So let's create,
and then
let's do A.
Well.
Okay, maybe call it A array or an A NumPy. Yeah, that's good. That's good.
Okay, and then do we want to make a copy of B as well as an array?
Why not?
Okay.
But let's just to demonstrate, let's do it differently. So with A, we're just gonna copy the array.
And then
with B, maybe use another function. So let's use the zeros function of NumPy. So it should be all zeros.
So
this is a second way to create a NumPy array. So
we need to give it a size, right?
Yes.
Was it like this?
Equals? No, you just give it as a. Actually, I actually don't know. It's just the first. It's just the first parameter of zeros. We wanted 10,000 of them.
Okay. So we want 10,000. Yes. We want them just flat.
For this example, yes, because we want to replicate what we did with the Python list.
So then we just run this cell. It won't do any.
Susa, a little tip. You can use underscores in your numbers
like
to separate.
like this
Yes.
to see that
So
it's
now you see that
1,000.
we wanted 10,000, but you only wrote 1,000 there. It's easy to see like this. And this is why it's so underscores in the little Python thing. If you write numbers in Python, you can put underscores inside your numbers, and Python will ignore them. But it's very useful for us humans to read the number, and now it's easier to
It's
see. Yeah, this is 10,000.
much easier to read. Okay.
Okay.
And
So
then
now
we want a new cell
Yeah.
to do this, and we'll start with the time it or
if we want to raise them,
time it,
yeah, let's do it.
and then we want to just
Okay, so now we want
b
b and
numpy
p. We want that to
equals
be a
np
squared.
squared, right?
Yeah.
So it was it like this?
No, it's 2
In
stars
NumPy? 2
in
stars.
Python.
Too many different programming
Yes,
languages.
it's a MATLAB. It's an R, I think. It's
Yeah.
But you got it correct. So we don't need to write any for loop for
Yeah.
this, which is a main NumPy thing. So a NumPy
Let's-
array is an object, and it supports many of these things, like adding things to it, subtracting things, and now squaring things.
Is
Um,
this it already? Like this is
This is it. We don't need anything else. Just try to
okay.
run.
Let's try this.
That's all we need.
This
It takes longer because it ran the loop 10,000 times because it was so fast. So now we're at 63 microseconds instead of 9.7.
okay.
Like we're an order of a magnitude faster in this thing. And this is just 10,000 numbers, not that big. But imagine if you have like you're an astronomer, you have like gigabytes of data loaded up, and you just want to, I don't know, remove a value from it or like do something to that data. This is why we need we need NumPy. We like to use NumPy for these sort of things. For one, we don't have to write for loops, and second, it's way faster.
Okay. Well, what's next in the
Okay.
lesson? Let's see.
So we already looked a little bit on how to create arrays. We saw 2 ways. We can create from a list. We can use NumPy functions. So okay, give me a bunch of zeros. I think
So-
there are a bunch here. I think a range is good to mention because I use that one personally a lot. So very often I want an array with the numbers 0 up to a number, and that's a range. You also have linspace. Maybe interesting to point out. So with linspace, you can create like increasing numbers, but it's more flexible. So with linspace, you could
an
say
exercise about it actually. Yeah, there is.
we have.
So-
Yes.
yeah,
Okay.
we
So
do.
okay, we'll leave it to the exercise. Okay. But before we go, we should talk about saving and loading. So if we have once we have our data in a nice NumPy array, we can save it, and we can save it with the save function. So maybe we can demonstrate that really quick.
Yes, we
Yes,
can.
Okay, maybe save our array and load it back again.
Is it np.save or is it
No, it's
and then you
np.save,
give
yeah.
it whatever you want to save. Say we want to save the B array.
Yeah.
And then you presumably need to give it a file name, right?
Yeah, but the other way around. So we do first the file name. I just had to look it up. I always have to look this up. Is it file name first or variable first? It's first the file name and then the
okay, so
variable you
this
want to save.
is
And
test.
yeah.
Save
And
and
I like to
NPI
give this
is
the NPI as an extension.
right?
Yeah. I like to do that.
Let's see.
Okay, that saved it to disk.
Mm,
Or it
and
should have.
then-
So now we have now you should have it there.
I should have it there somewhere.
You called it test save.
I did.
Oh, there it is.
There it is. Can you actually see that on my shared screen? I hope you do.
I think so, yeah.
Check with the.
It's all the way in the bottom, but yeah, we can.
Yeah, because
Okay.
I named the test.
Good. And to load it, it's the np.load
Mhm.
function.
So if we wanted to do np.load, then
You just give it a file name. Now it's easier. We probably want to save it to some variable if we load it as well.
true. We were have A and B. Let's go do C.
Sure.
And then
Maybe just let's try that. Okay, it's loaded. Okay, one bonus thing. Can you quickly create a new cell? I want to show you
Yep.
another NumPy function. So now I want to know whether this worked. So if this works, then B and C, they should be exactly the same matrix.
Yep.
And there's a function for that. It's called np.array underscore equal.
Like
And you
this.
give two arrays. So in this case, B and C, and then it will tell us, are they the same array? Or do they contain the same numbers? And it is. So it will very quickly go over all the elements and check if they're equal, and they are. So this worked. Okay, I think it's time to let our participants now play along around with NumPy a bit.
Yep. All right. So
But before we do that, we need to explain a little bit about data types. So now we've been enjoying NumPy and it's like amazing speed. But the reason why NumPy is so fast is that all our elements in our array, they need to have the same data type. And so if you're familiar with computer science, you might know what I talk about, but if you're super new to Python, this may be a new thing. That variables in Python can have different types. Like we have an int type. An int means a whole number. We have a float type, which means a number that can have a decimal dot inside. If you have like pi 3.14, that would be a floating point. We have strings, which are these things in quotation marks that we keep writing, that is like a bit of text. These are different data types, different types of data. Inside a NumPy array, all the elements, they need to be the same type. And it's relevant in NumPy. So each array keeps track of what data type it is. And it's stored in D type. So maybe we can quickly check for one of our lists in our notebook, like what's the D type of this? What's the data type of this data? It's probably floating points of them. Maybe check it for A and check it for B, because they might actually be different. We created, I think when we created A, we created a bunch of integer values, int.
like this.
Yeah. Yeah, it's an
So we've
integer.
got
It's even
int
relevant that it's a
and
64-bit integer, which is something in normal Python you absolutely never have to deal with. But in NumPy, these things are relevant. Hey, and our B now is a floating point of 64. That's probably because we started squaring very huge numbers.
likely.
Likely. Yeah. Okay, but so that's the thing. And it comes up in the exercise as well, that you have different data types. That's why I want to mention it.
Yeah.
All right. It's high time to go to our first exercise now, I think.
Indeed.
Yeah. Okay, so to you, all the participants, we have our first exercise. It's an exercise in creating NumPy arrays in various ways. So go check that out. I think we will give them.
Given that it's relatively late already, maybe
Yeah,
we try
5
to
minutes.
keep it to 5 minutes. One
Yes.
reminder, what you absolutely have to do, as always in Python, if you want to use something that's not base Python, you need to import it. So for anything that for the solutions, we always assume you imported NumPy as NP.
Yes. Very good. All right. Good luck. We will see you back in 5 minutes. everybody. We're not actually back yet. Now we're back. Welcome back, everybody. Okay, I hope you did well with the exercise. Susan, maybe we can go through the solutions really quick.
Yeah, right. So we wanted first to do some arrays basically.
Yeah.
Creating them with arrange and with linspace. And I mean, I run this.
What's different?
There's little dots here.
There's dots there. Yeah, that means that the second one, they're floating point numbers. They're numbers with a
Okay,
decimal
so
point inside.
so
So
we talked about D type.
Mm.
Can I just do this and then tell it to do ints?
Yes, you can. And now they're integers. Yeah.
Yeah. Okay.
And with the A range as well. With the A range, you can tell it I need them as floats if you want to.
Like this.
Yeah. This will sometimes come up. So when you try to add float to integers and other way around, it may at some point NumPy may complain. Let's see. The second one was creating some random numbers.
Yeah. Okay.
So when this is relevant, so say if we create can you create a 3x2 array of random float numbers? So it's numpy.random.random. And then you give it the shape as a tuple. So we need another pair of round brackets. Yeah. So a 3x2 array.
3x2.
Yeah.
Three
so if we
rows,
just
two
do
columns,
that,
yes?
yeah. If we execute that, we get, well, floating point numbers, okay? But what if I now were to say, no, I don't want them as floats, I want them as integers. So can you, but maybe at the end do dot as type, then we, well, yeah, you can also do it like that. But maybe maybe show a different way of doing it. Okay, but this works, okay.
And then the other one would be as
yeah,
type?
that at the end you do dot as type. So if you already have an existing array, and now we want to convert it to some different type, you can use dot as type. Integers. Yeah. And exactly, you can write it like that. So now I've created random numbers as integer values, but now they're all
0.
Because they were between 0 and 1, we now convert them to integers. Integers only store like whole numbers, so they all get rounded down to the nearest whole number, which in this case, they're always rounded down to 0.
Is it if I do this with a D type int?
You should get the same thing, I think.
Uh,
Oh, it doesn't actually do it. So random, I guess.
Random doesn't do it. But can we make random give us like integers?
With a different function we can. So there's a function called rand int.
I mean, can we?
The
thing is, how do I remember all of these different options?
That is a good question. Well, the first answer would be is to check out the great NumPy API documentation. So in this course material, every time we mention a function, these are all links. So you can click on them.
If I click this,
and it will take you in a new tab, probably. It will take you straight to the NumPy documentation about what this does. And now in the NumPy documentation, it's, okay, these are random numbers. So how do we create integers now? We can, well, yeah, it's already there. We can also go up one level in the API documentation.
Okay.
There's this breadcrumbs. You can go to random sampling, for example, and it will.
Like that one?
Yeah. And it will. You can scroll in. It will give you all the like different functions for random, like computing random numbers and other things. There are so many functions. So that's one way. Another way I would like to show you is inside the notebook itself.
Okay, give me a second to get back to my notebook.
Yeah.
Because it's a bit difficult with the.
Now with the thing.
Yes.
No, now our screen share is a bit
Is
wonky.
it entirely? Yeah, that's because my screen is
Oh, no.
off whack entirely. I'll put this aside and redo it.
Yeah.
And let's get back
Okay,
to
that's
the
we're back.
notebook. Right. So how do I do
So
it?
inside the notebook,
Mhm.
of course, we have we have our big friend tab completion. So if we just have numpy.random and you just pause for a bit and we press tab, it will
Yep.
it will show you all the different functions that start with random. So there's our friend random integers if we want to generate random integers. It's right there. Then if you want to know how to use that function, what you can do is now just append a question mark to what you have now.
Like this. And then execute.
And then execute that.
Ah,
It will give you
the documentation.
the documentation for that function right inside your notebook. This also works in an IPython terminal, by the way. That's
nice.
so that's useful. Okay. Hey, but we need to keep going.
Yes.
That's good. Okay, so with random integers we can create numbers between random numbers between 1 and 20 or something if we want them. All right. Yeah, we already showed how the IO works, and well, maybe quickly show how to reshape an array. I think we haven't talked about. Actually, we haven't talked about that. So right now, all the arrays we've been creating were one-dimensional arrays, basically just long lists of numbers. But a really useful feature of these arrays is that we can create two-dimensional grids or three-dimensional grids or 12-dimensional grids. Let's see. So now you give it as a two. Yeah, you have one pair of round brackets too many there.
Yeah. Okay.
I think it's just.
No, I don't.
Oh no, you.
It's just that it's.
I don't.
Let's just go to random.
Yeah.
Let's just do floats.
Let's do random floats. So maybe.
And then we had 3 and 2, right?
Yeah.
And then we wanted to reshape.
So we can reshape that to other shapes. So what can we do? We can reshape it as a 1x6. That works. Or
No, this is still a 3x2.
So you need to assign it to x. So x equals x dot reshape. Yeah. So now it's a flat list. So this is things we can do: 3 to 2, 1 to 6. Can we reshape this as a 4x3 array? That was
4
the
by
exercise.
3. But there's not enough.
No, it's not. Yeah, it's not gonna work, right? So it needs to be.
There's not enough data there.
We have 6 numbers. They need to remain 6 numbers, right? So we can put them in different shapes, but they need to be 6 numbers. Okay.
Yeah.
Okay, let's go and change topics and do a bit of math on these arrays. I think we've now seen many different ways of creating them.
Yeah.
And reshaping them, and that they have data types. But now, what if we actually want to do some science on them, at least some math on them? So can you maybe copy from the lesson materials and just
let me
create...
get the lesson materials back to
if they're
the shape that people can see.
Yeah.
Math. So like this one, yes?
Yeah, let's copy that. So that piece of code gives us 2 little arrays to work with. Okay.
A and B.
Yeah.
And then we add them.
So
and multiply.
Yeah, basics first. Basics first. So we can arrays. We can add them together with plus, or with the add function of numpy. They do the same thing. We can multiply them together in different ways. And if we want proper mathematical matrix multiplication, we use this add sign that you also use in email addresses, or you use the numpy dot function.
Let's see if I execute this.
Yeah,
It doesn't do anything because it doesn't print. Well, it does
it doesn't
something,
print
but it
anything.
doesn't print anything.
You can add some prints there, or so maybe print A and then
What was it? B.
yeah. So maybe show the matrix multiplication. So maybe print A, print B, and then also print E, which was a, or F, which was a matrix multiplication.
And print E.
Okay. Well, it's a bit hard to read. It all prints them right after each other. But we have two 2x2 matrices, and we can matrix multiply them. We can do other things. We can subtract them. We can multiply things. We can divide. We can compute square roots. But rather than us showing that, I think it's better for the participants to try that out for themselves.
Yeah.
Oh, this is way better.
Sounds
Thank you,
like
Susa. Yeah.
that sounds like a very good idea.
Okay, so let's go to the second exercise. We will give you
The
5
second.
minutes again to create to create some arrays and play around a bit with matrix multiplication, doing things like computing the sum along some dimension. We will let you play with it first, and then we will cover the solution, what we will see. Okay,
So
we
it
will see you.
is 11:36 now, so meet you back at 40, I would say.
Yes,
let's 4 minutes, but I think let's be quick about this. And bye for now. See you later.
See you.
Okay, and welcome back. So at the moment, you have had a look at the exercise 2, looking at these different matrix multiplication functions. So multiply, it sounds like multiply should do what we want if we want a matrix multiplication, right? But does it?
It doesn't. So multiply does element-wise multiplication, and if you actually want proper matrix multiplication, you want to use the dot function. This
Okay.
is why I generally advise to just use star and the at sign,
Yeah.
which do the same thing as these NumPy functions. So we could also say they're syntactic sugar. So they just look nicer in your code and a bit more clear.
Yeah, because we're used from our school math to have this sort of infix notation, right? Like where the operator's in the middle.
Exactly.
And then there was something about specifying the axis.
Yeah.
Are we doing dance now or something?
No, it's okay. It's yeah. So well, when you use the NumPy functions, a benefit of that is that these functions have loads of different parameters that you can set. So if you want to compute the sum of an array, there's a function for that. It's called sum, and by default, sum will just like sum all the values in your array together and give you a single number back, like complete total. But what if you want to compute like the row-wise sum? So for each row, we want the sum. Or we want for each column, we want the sum. So this is where the axis parameter comes in. When you specify axes, you can tell it. So rows is axis 0, columns is axis 1. And then you can do the same for 3-dimensional, 4-dimensional, 5-dimensional matrices, and the axis just increases. It's a very useful thing to do. That brings us a little bit to how do we index and slice up arrays. So now we've been working all the time with like we created an array and did something to the entire array. What if we want to do something to part of an array?
Like only the first row.
Yeah. So then we need to select that first row. So this is an important NumPy thing to do. And you can already see now from the materials, it uses the same syntax as Python lists do. So NumPy arrays try to be a little bit like Python lists, only they're much more powerful because for one, they're multidimensional. So we can do things as take the first 3 rows and then also take the first 3 columns. And you can even do complexing, and maybe we can show that in a notebook. We can we can index like this really specific elements from an array from multiple dimensions by giving by giving it
maybe
2 tuples. But maybe you can copy that, and
I'll just copy the whole bit and go to my Jupyter. Let's put this here. And then paste it. So we're making a matrix named A that is 4 by 4.
Yeah.
And then we want the first row, the first column. See what we get.
The middle out of that. But that final one is interesting, right? So the final one, it selects 2 values. So we can like select like specific elements from a multi-dimensional array by giving 2 tuples, and we give 1 tuple for each dimension in the array. There's a 2-dimensional array, so we give it 2 tuples, and the first tuple contains the values, or not the values, the indexes along the first dimension. And then the second tuple gives the indexes across the second dimension. So in that we say, okay, we want the value at index 0 along the first dimension and 1 along the second dimension. And then as a second value, we want the value that is index 1 along the first dimension and 1 amongst the second dimension. So it's difficult to wrap your head around, but it's a really powerful way of,
Let's see what we get.
if you need arbitrary unit. This is great. Yeah, if you want
So-
arbitrary things.
The original is 0, 1, 2, 3, 4, 5, 6, 7, up to 15.
Mhm.
And then we want did we say we want of the first row, the second element?
No,
Is 1?
no, that's not how it works. So the
What is it?
The first tuple tells you we want from the first row. So the first
Yeah.
tuple deals with dimension 0,
Ah, so it's the first
and the second
row
tuple deals
and
with dimension 1. So it's just
so we want
that's it.
the first row and the second row, and we
Yes.
want from those the second element and the second element again.
Yes. So pairwise. So it's a little bit difficult to wrap your head around.
Oh yes. So if I wanted like the third row as well and the same,
Mm.
I would go like
And which
this.
element in that third row do you want?
The first again, or the second
Okay,
again, I
the
guess.
second again. Okay, so that should be the
Try
9,
this.
right?
Yeah.
Okay. So what
I
if you
think that's-
wanted to select the 11?
The 11, then I would have to go not 1 in the second, but 3, I think, right?
Yeah.
11 is the last one. Yep.
Yes, you got it. So okay.
Right. I think this example is
If you mastered
it-
this, you have mastered indexing in NumPy. I think compared to this one, all the other ones are easy because they behave a little bit like you would index a Python list. It's in the same way. Okay.
yeah.
So, okay, one other really powerful way we should definitely show is Boolean indexing. So
Yeah.
what if we take this matrix A, which is a nice example. What if we want
Yeah.
all the elements that are larger than 5?
C equals A. Is it A
Yeah, A is larger than
than
5.
5 like this?
Yeah, that would work. And now the question is, why does that work?
I guess what we could also do is just A larger 5.
Yeah, print that.
Because that
Yeah,
would get
that one.
no, that won't. Let's remove these other prints. We already know what A looks like. And we're not really interested in B at the moment.
Maybe first print, what does that do? That's a Python statement. A is larger than 5. What does that do? It does something to our array.
Yeah.
So it turns it into a Boolean. So A larger than 5 will give us a new array. Now it's of data type Boolean, and we'll give for each element whether it's true or false that element is larger than 5. And we can use that to index an array. So you can, this is called Boolean indexing. So if you have an array with values true and false, depicting which elements you want to select, yes or no, for each element, if you have such as an array, you can use that as an index into another array.
Does it have to be the same size?
They would
Or
have
could
to be exactly the same.
if I want to use if I want to be a bit more complex than I need to be, and say I wanted to select the first 5 elements, could I just give it like make an array that is true?
I mean, you now don't make them string values. Yeah.
Yeah, true. Not string value true.
Okay. So true.
Let's keep it at 3. Fine.
Okay.
And then I want to select a I want to do that.
Sure.
Print it so we can see
Maybe
it.
get rid of the print C then at the end.
Yes. On it.
Yeah.
What happens?
Well, you get an error. So it needs to match at least one of the dimensions. So if you
So
just
if I did,
if you add 2 falses to that,
it's 4 by 4, so 4 should be fine.
sorry, it's 4 by 4. Yeah, so 4 is fine. So now it's all true. So now you
Yeah.
can turn like rows on off and on. Okay. Okay. So yeah, it's high time. We have 10 minutes left.
Yep.
But for our lesson plan, it's important that you guys try exercise 3. And after exercise 3, we'll get to our final point of our lesson. So I would invite all the participants to play around a bit with indexing, which is what exercise 3 is all about. But exercise 3 will also give you a surprising result. So go try it and get your surprising result, and we'll be right back. So we will give you, again, 4 minutes to do this. We'll be back at 55 to reveal the surprise and talk about our final point. Okay, good luck.
Bye.
And we are back. Welcome, everybody. I hoped you had some fun slicing arrays and maybe found something interesting that we create in the first line here in the exercise. We create an identity matrix of 4 by 4. And then in the second line, we use this slicing thing. We select a single column from our array. And we assign it to B. Okay, so now we have array A and B. And then we modify a value in that array. We didn't really talk about it yet, how that works, but you can see now in the exercise, you can assign values to slices and things. But let's quickly run that in the notebook cell. Can you quickly run that, Suza, and see what happens?
Yep.
What happens to matrices A and B
Let's see.
when we do this?
Brand new cell.
Yeah.
Lots of history before, but let's ignore
Okay,
it.
do that, and then show us what A and B look like afterwards.
So I'll add some print statements. Print A here,
Yeah.
and print.
So can you print A and B both like at the end?
And that's for clarity. Add just a line up.
Oh, yeah, this is perfect. Yeah.
Right. Let's see. So A is an identity matrix. One's on the diagonal, zeros everywhere else. And then we do we assign something to B. And now we print A. This is A, actually.
Yeah.
And this is B. We didn't change anything about A, though.
Yeah, but it has changed. So this is an important thing to note. When we selected a single column out of A and we assigned it to B, what we did is create what is known as a view. So NumPy is designed to deal. NumPy is designed to deal with huge grids of data, and if it can avoid it, it will not copy all the data all of the time. So it's super fast in selecting like a single column. And the way why it is that fast is that it will not actually like create in memory a duplicate copy of that column, just that column, and assign it to B. No, it will keep the same underlying memory in your computer memory, and will just like create, well, we have now a new array B, and it just uses this column, but it will not actually copy any data. So now array A and array B, they use the same bit of memory in your bigger computer memory.
How does it know where the column is?
So it's the data pointer. So if you go to array A or array B, they have a .data attribute. Is that your question? Or so
well, actually, like, how does it? I mean, if it wants, you can select anything from an array. How does it not? How does it know where that data is, but not have to make a copy so we can do things, know where it is fast?
Okay, well, for that, an array, it contains 3 things. It contains one, a pointer to the big data array in memory, and that should be for A and B. That should now be this like point to the same memory. And then it has an attribute called size. It has an attribute called shape, and it has an attribute called strides, which tell that array, okay, which part of that big block of memory, which part is like my data array, and what kind of shapes do we have, and where do we find all the data. So those are just attributes of the array.
So basically, it relies on it being always the same size.
Yes.
All the rows and the columns being a fixed size, so
it does
that it knows
in order to do the
where is what.
Yeah. But if not necessary, so reshaping, transposing, or just selecting a row of a column, it will not like create a new copy of the data. Something to be aware of. So then if you modify one array, it may also modify the other array, other array, like the data in that, because they share the same memory. So it's now 12 o'clock. So our final message here is, if you do not want that to happen, there's a copy function. So NumPy has a copy. You can just say, create a copy of 8. That will actually create in memory like a whole new chunk of memory it will assign, and it will copy the data there. So now you actually have 2 independent copies that you can work on. So that's like a caveat to do. Now we just skimmed like the tip of the iceberg here. NumPy is a huge package. We covered some of the basics for you. What we did not cover is the absolutely enormous library of functions that NumPy has. If there's anything you want to do to a bunch of numbers or a vector or a matrix, there's probably a NumPy function to do it for you. This includes like things like linear algebra, if you want to do an eigenvalue decomposition, if you need to invert a matrix, if you need to do a linear regression with that, there's tons and tons of functions in the NumPy library. So with that, we will end this session. Is there something like closing remarks you want to do, Suzanne, before we end?
Well, if you want to get more of a structured teaching like intro to a bit more detailed NumPy topic, you can continue reading this lesson, and then there's also an advanced NumPy lesson that we will not be teaching this year, but it is still there. The materials are still quite good to use.
Yeah, they go really, the advanced tutorial really goes into the nitty-gritty details of NumPy, how it works.
So that's one of the, I would say it's recommended reading.
Yes.
For the interested reader.
I think so too.
Right, but that said, now we've got an hour lunch break.
Yes.
We will be back at 1 o'clock here in Finland, which is accordingly 12 o'clock in Central Europe, Central European time zones anyway, also in the Nordics.
Yeah.
Yep.
So yeah, 1 hour for lunch.
I'm subbing in for Enrico for a little bit. But yeah, just essentially saying that. So we're going on a lunch break, and after that we have in the afternoon we have pandas, an X array. First with Susa and then with Marine. So I guess you can maybe advertise just like 10 seconds. What is X-array? What is pandas?
Oh, with X-ray is, I was just talking about that with Susa. So if we showed we have this dimension, like we take the sum along dimension 0 or along dimension 1. What if we did not have to use these confusing numbers, and we can just give names to dimensions and give names to our rows and our columns? Our life will be a lot easier, and that's what we're going to talk about in X-ray.
Okay.
Well, and well, to me, pandas is if you want anything that looks a bit like a database but isn't a fully fledged database, operating on larger amounts of data, merging them, joining or whatever things you might be doing in Excel or might be doing in an actual database, and you want to do it in Python, that's what pandas does for me at least.
All right, but yeah, let's go have some lunch and see you.
Bye, everybody.
At well, at the hour, depending on your time zone.
Right.
All right. Bye.
See you, everyone.
Okay, hello.
Okay.
We should be live. Welcome back from the lunch break. I'm looking at the wrong camera. Okay. Welcome back from the lunch break. I hope you had enough time to get lunch and stretch your legs, and it's going to be a couple of interesting lessons still. So I guess I shouldn't spend too much time here. Just go into it so that we don't go over time. So first we have pandas and then X-ray. So, yeah, go ahead.
Yep.
Yeah.
So it'll be me with you today again. And with me, I've got Ashwin. Ashwin, do you maybe want to introduce yourself? I've done that in the morning, so I'm not going to bore everyone else again.
I'll do that. So my name is Ashwin. I'm a researcher in rice in Sweden, and I work at the memory factory. So let's get started, I guess. So in this episode, we will be introducing a new package. In the morning, you saw NumPy already. So now you'll be looking at another package, Pandas. Pandas is a package which can be used to read data structures which look like a table or a spreadsheet. In general, one can say it's a tabular data. And we'll see like how we can use that to make use of in your research. If your research revolves around with dealing with such tabular data in form of spreadsheets or CSV files, or even databases for that matter, you might find something useful. So there are a lot of utilities inside Pandas. We won't go through all of them, but the idea is to give you a taste of what can be done. And the best way to find more information is from the Pandas documentation. So here we have handpicked a selected few tutorials from the Pandas documentation itself. And also they have the extensive, well-documented functions and methods that you get from Pandas.
Also, then like an API documentation, just like you had for NumPy.
Yeah.
I'll try opening this documentation in a new window so you can just quickly see it. Takes a while to load.
Yes.
So you've got all sorts of, you can get it started. If you want something on a specific function, the API reference is your friend. And that gives you, it's fairly similar to the NumPy reference. Gets you information on basically everything you could want to do.
Yeah.
So just as a quick excursion, let's get back to the lesson.
And then, of course, there are other ways, like the cheat sheet can be like a one pager. So if you're getting lost and you don't know what to do, you can also take a look at the cheat sheet, and that should give you a quick recap of what we have been talking about. Okay, so without further ado, let's try to explain things while going through an example. So the way you import pandas, and you should have that in your Condas environment already, is to write this statement, import pandas as MPD. So what we're doing here is we're putting it into our current Python interpreter, and we're giving it a short name. So we don't have to write pandas all the time.
I guess you could call it X, Y, or Z if you wanted to, but then these are usually variables, and PD is, I think, the most common shorthand for pandas. So if you find code on the internet on Stack Overflow, they usually use pandas as PD.
Exactly. Yes. So this is some sort of convention like people use. And what we are going to use as example data is a CSV file provided in the Pandas source code itself. And Pandas comes with a lot of read utilities. Everything starts with pd.read underscore something. So if it's a CSV file, you do pd.read underscore CSV. Shall we?
Maybe
Yeah,
actually executes this. So I've already executed this import pandas as PD.
yeah.
And now if I read this in,
Mm.
it'll take a while, but now it's executed, and then we can, I mean, I've already done this, but we can do it again. Then we've got the start of the CSV file, the start with the table of passengers on the Titanic.
Right. If you go back to the read operation, let me try to explain what is going on. I mean, you can be in the notebook as well. It's fine.
Yeah, I'm just hello.
No worries.
Trying to hello.
I
Sorry
see.
for the yeah, I know
Yeah.
my computer was frozen.
Okay.
I'm sorry.
If you scroll back up a bit.
I scroll back up a bit.
Yeah.
Right.
So what we are giving as input to read CSV is a web address, a URL. So Pandas makes it easier for you to download it on the fly. And it recognizes that from the HTTPS in the beginning of the string. But this is not the only way. Like it could be a file path in your hard disk. So instead, if you download it yourself and give it instead of URL a string which points to the file path, either relative to the current notebook or an absolute file path, it should do the right thing, exactly the same. And you see an argument called index call. So this is something which is particular to pandas. So if you notice the output below, I'll tell you what head does in a moment. You see the first column is marked in bold. So pandas has a way to do indexing based on human readable names by setting the name column as the index column. It gives some special powers so that if you can access in terms of name any row in this CSV file, which is loaded as a data frame. And in the same way, any column can also be accessed by the headers in the CSV file. So the first row is treated specially usually. If you want it, that's the default. And those get assigned as columns. So if you remember your episodes from NumPy, every time we wanted to index a row or column, you had to use an integer. That, of course, is possible. We'll come to that in a while. But here, index is the name of the first column, and column names are on the top. And then typically, you don't want to see all the rows in the column unless you want to. So that's why we use the head method. And you can choose to see the default, which is 5 rows, but you can also to see 10 rows as well, or 3. Yeah. So that's of
Oh, you
course
just get
possible.
3.
Right.
You still get the whole columns, right?
Yeah, you do. You do. And if it's like 1,000 columns, I think it will try to truncate it. It will write ... and then try to hide the whole visual overload.
Right. So what do we do with this data? It's this pandas data frame now, because this is actually, it is a data frame, right?
Yes,
But what is a
exactly.
data frame?
So a data frame is a representation of the of this tabular data in the memory, and it's a unified format. So if you read from an Excel file, which is also possible in Pandas, they get loaded as a data frame as well. So there is no conflict depending on what format it's coming from. And also there are some special properties. For example, if we write titanic.info, we will see how they are stored in memory. Yes, exactly. So we see that it's a data frame and it contains a certain number of columns, 10, 11 columns actually, if you exclude a name. And each column, like pandas being smart, it gets assigned some data type. So these are from the NumPy data types that you saw before. So if it detects that all the column values are integers, it tries to assign it on its own. But if it's unable to guess what it is, it will give a universal type, which is object.
For example,
some
the ticket or
yeah,
camera.
exactly. So maybe
Yeah,
it
okay.
contained some special
A combination of letters and numbers.
right. Yeah, it was unsure, and there were some missing values, so it was unsure if it's a float or it's a string. So that made it second guess things.
Yeah.
Another way to get an overview of a data frame is to type the describe method. So this is very common to do, and it also gives in some sort of statistical overview of the data frame. For example, for every column, how many values are there? You see that, for example, in age, there are some missing values, probably 714. And you also see some like the probability distribution of things. What is the mean? What is the min, max, and all percentiles in between in this distribution? The standard deviation as well, if you understand that. We can get maybe some guesses like what was the age distribution like. The average is around 29 and the 50% percentile is 28 and so on.
So the 50th percentile is basically the median, right?
I think so, unless I'm awfully wrong. I was unsure, so I didn't say that out loud.
Yeah, well, so and the maximum is 80. So the maximum age of any passenger on the Titanic was 80.
Right. Yeah. So this is now some simple analysis that you can do. But now if we can also try to do something like a group by. So we can try to combine two different columns and to get something much more useful. So we'll try to do yes, Titanic group by, and if you choose the
by uppercase or is it lowercase? I think it's lowercase, right?
lowercase, yes. And we can choose the survived column for this example. And right. So this will
this was
group
sub-selected, right?
Yes.
In some way.
So just to give a understanding, like survive column here has two different values, 0 and 1. That will try to group into two different groups, and we can choose the age column out of this group by. So if you do square brackets and type age, and then we can do a mean, I suppose, so that we don't see the whole distribution of ages. Yeah.
Was this printed automatically? Not.
I think this should do it. Yeah.
It does. Okay.
Yeah. So we see in a very condensed form, like if you were alive, you were probably younger, of the average age of 28, but you're slightly older, 38, you get unlucky in the Titanic. You can also do get the same thing out in histogram fashion. So that's an example code from in the lesson, which uses titanic.hist.
Yeah.
Let's
And
take
then
a look at that.
I'll just copy that from the lesson material.
Mm.
Paste it in here. So this should get a histogram
Mm.
over ages,
Mm.
grouped by the survived
Yes.
column. And
Right.
then we're telling it that it should split it into 25 bins. So
Mm.
when you do a histogram, you put things in bins that are relatively similar, and then it will actually should create us a figure
Yes.
with the
Yeah. And at this point, maybe it's maybe useful to, if you go to near titanic.hist and press Shift Tab, you can get the inline documentation, I think. Shift and Tab. Yeah.
Okay.
So you get a clue
Mhm.
what kind of parameters are there if you're feeling lost. And that's one way to get help in Jupyter. Another way is to do titanic.hist. Question mark and pressing enter. That's also
Yes, that is
possible.
something that we looked at for the when we were looking at NumPy functions. But Shift
Yeah.
and Tab
Yes.
also helps. That's nice.
Let's take a look
Let's
at what we
see
get.
that. Yeah, it's computing.
Yes. It takes a while to plot and make a distribution of these things. So what when it's done, you might be able to see two distributions, each for the values 0 and 1. And we'll see the one with survived equal to 1 being peaking at around 28, I suppose. I mean, we have done some binning here, but the idea is the same as the group by that we just did.
Yeah. So presume, yeah, with 25 bins, what do you think? Will we see a difference in where the peak is?
If the bins are like 3 or 5, then you'll definitely see a difference.
Yeah, somewhat. You've got the peak for the
Right. So it's distribution is not symmetric. So maybe mean is not the right. So you also see something better from visualization.
yeah.
Maybe mean is not the right metric. You might need to go for a median instead. Right.
We can actually try this. I mean, it's all built in anyway, right?
I guess so.
If we get the median.
Yeah.
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 And we have the median is pretty much the same with
Okay.
for both
So there was
groups.
no real bias over there.
No real bias.
Yeah.
For
Okay.
who survived or how old the people that were survived.
Right. Shall we take a look at a recap of what we saw so far in the lesson?
Yes. I will put the lesson document. So we have done these bits.
Right.
In the group by and the histogram.
And then we saw how to get the column. Yeah, right. I didn't think I think it comes later.
Yeah.
How to access column.
Maybe we should.
Yeah, this is a nice view. So a data frame is just to recap things. It's composed of rows and columns, and it has a special column called an index, and the top thing is the column names. And you can get some information about how the columns are used by doing .info or .describe. And each column of this data frame, which is a 2D structure, is stored as the pandas.series object inside. So every time you access a special column on its own, you will see that it's a .series, pandas.series object. How to access a column is given below. Like you can either use square brackets and type in the column
like we
name.
just did.
Yes, but sometimes it can conflict. Suppose if you have a column name called describe, then it will get confused. Are you asking for the method? If you're using the Titanic.h without the square brackets syntax, it might. So that's why this square brackets and the string notation exists. You can also look at what the data types are using. The type built-in function, it's universal in Python. You can use it outside of pandas as well.
Yeah, and as we already saw earlier, you can also see the data type in the series with the info function. Because
Exactly. And we saw that columns can be accessed and index can be accessed like as shown here. And we already saw like what those are, what is an index and what are columns. Another way to access a particular value is using the lock and the at method, special methods called lock and at. So this are quite similar in sense that you can when you compare that to NumPy, like when you do slices of NumPy. So the previous example where you just put square brackets, that's a short form for the lock, I think.
Yeah.
And you can also do ranges. So should we look at some of these examples in the notebook?
Yeah, we can do that. So let's add a cell, and then we want to maybe do from the Titanic data set. Maybe we want to get the first row. So I would go if I don't know which row is the first row, what the index is of that row, but I know that I want the first row. I could go log, right?
Yes.
And then that would be not square brackets, but round parentheses.
In square brackets, yeah.
In square brackets, is it?
Yes, yeah.
Wrong type of bracket. And then we want the first row and all the columns.
And all the columns, yeah.
Is that?
That should give you a slice, I think.
Let's see. Of course, it doesn't print it now because
no, you give the name. Yeah. Right.
And then it's got.
So you will get the first row also as a series actually, because it's a one-dimensional thing.
No, it's not a series. It's a data type object.
Can you check that maybe? Type of first row? Yeah.
At least I think. Let's see.
Maybe I'm mistaken.
Okay. Oh.
Yeah.
Oh, it is
okay.
a series. Okay, you were right.
But maybe if you ask for more than just the first row, maybe the first 3 rows,
yeah,
or
I guess I could like
0 to 3. That would be the first
that
2
would be
rows. Yeah. Now it's the first 3 rows.
Now it's actually the first 4 rows.
Yeah, and now it cannot be
And
compressed
then,
into.
yes.
Right.
then it is a data frame again.
Right. Yes. Yeah, if you use a print function, you get a text-friendly representation. If it's just first rows that you give, then you get a more Jupyter-friendly one. But that's something Jupyter does for you. It's along with pandas. So the lock and iLock comes in pairs. If you use lock instead, you need to know what the names of these people are in the first row and the third row.
Because that is the index.
Right, which depending on the data can be useful or not useful. Usually like the column names are very descriptive. And you can also do ranges with these string based names. One difference is that the at operator, because it's newer and it doesn't do a lot of checks, it's supposed to be a bit more faster. That's maybe not so much difference that you'll see because it's a small CSV file, but if it's a very large data frame, the at which looks very similar will be slightly faster.
So how does that go? I haven't ever used that one.
It's exactly the same syntax. So if it's integer, then it will be I at instead of at. Integer indexing, yeah.
And then that gives us?
Like it says the same thing, I think. Or not.
wasn't at actually the one where you
right. So you cannot do ranges then. You can only get a scalar. Yeah, sorry. Yeah, that is a small difference there too. Yeah. So if you're only interested in one element,
like the very,
like
very
that.
first element.
Yeah.
Is a one.
Hmm.
Maybe that is not very useful in this case because we don't know what we're doing. But if you do it with the at, you then give it the name.
Right. Yeah. That can be more nicer to look at.
And then
you can age maybe.
Let's see what his age was exactly.
So that's more descriptive. Let's try to see how you can do Boolean indexing. Now we saw strings and integers. We can try to see who are older than the age of 70, for example. So that we do that.
Do it with
just the square brackets.
Yeah. And it's the same as in NumPy, basically. You create a
mask.
Yeah, a Boolean array, basically, or a Boolean representation of the data frame, or in this case, I think it's of the time series, that like all the rows, and then it will select based on that Boolean array.
Right. It will get back all the indices where this is true, and then that serves as a mask for getting a slice of this data frame. It satisfies this Boolean condition. So the condition can be something like greater than, but you can also look for string-based Boolean indexes. And for that, like there is the example in the lesson. It could be useful if you deal with a lot of strings. There are other useful things when we deal with missing data. Data is often very messy, and you can fill with empty. It might be filled with like missing data, which gets represented as NA in or not available in pandas. This is a generalization of the NumPy not a number. It's a can include not a number values if you are dealing with just floats, but if it's a generic thing, pandas call it NA. And you can either get a Boolean mask of these NA values using the isNA method. You can choose to drop every row if any of the column values are NA, so the whole row will be dropped. So
Yep.
yeah, and then there are other ways to do that too. You can also fill it if you want. So there are some useful methods. I think it's time that you get your intuition with it by exploring through an exercise. So let's take an exercise for 10 minutes. Here you'll be using the same data set and try to do 2 tasks and any of the methods mentioned above. So exercise till 43 past the clock.
Okay. All right. Do we have a notes helper to put the time? We want to stop the exercises 43 past the clock, and
Yeah.
we're gonna be saying bye for now. See
Yeah.
you in 10 minutes. -ish.
Yes. Hello, welcome back. I hope you got some time to look at the small exercise. If not, we'll show it to you anyway, like demonstrate it. So in the last 2 points of the exercise, the first task is to compute the mean age of the first 10 passengers, the first 10 rows, the data frame. So the way to do that, you can, as shown in the solution below, you can either use the iloc based indexing or with integers, or the loc indexing. It's string based. So we chose the first one because it makes sense.
If you know the first 10, you want the first 10, then it makes sense to not look up their ages, like the names, and just say, I want the first 10.
Exactly.
And it's
And we get
pretty
the
average.
average. Right. And the other task was to find who are older than the mean average age, or who are younger, over and under the average age, and get their the mean of the survived column, if they were more likely to be survived or not. So we chose the one for the older people, Titanic age greater than.
Yeah. But I mean, the younger would just be inverting this relationship, and
Exactly.
then you get well. So the older ones were slightly less likely to survive.
Maybe so.
I would say.
Good.
Not so good.
Yeah, right. So this was just a repetition of what we saw so far, indexing and creating Boolean masks and doing small statistics like mean.
Yeah.
So now we take a look at how data gets represented. So this is borrowed a lot from the R tidyverse theory of representing data. I saw briefly in the notes that some people were comparing this to SQL and R data frames. So it is true that this pandas package was very much inspired from these two libraries, which pre-existed at pandas, I think. If you talk about tidy data, like the best way to represent the data is to have every variable in its own columns, and each row is an entry or an observation. So what would be the inverse? Untidy data. Like here, there is a synthetic data of some runners, runner 1, runner 2, and runner 3. And what we record is given below, given over there. And if we print that runners, how does it look like, Susan? If we,
I guess I have to print it, actually.
well, just runners is good. It looks nicer, I think, without the print.
Well, then you don't see it.
You do.
You mean
I like that.
just
Yes.
like that?
Mm-hmm. Yeah. So what we are seeing here is all the distances that they run as columns, and the runner names as the first column, and the timings get represented in the interior of the data frame. So suppose you want to do something very simple, like calculate their speed, then you want to do distance divided by the times, right?
Yep.
The operation gets really messy, and you will get a new data frame. You don't have any place to put that here. And it's also difficult to access the distance from the column names like this. So the way to make this into a tidy format is to use, for example, the pandas melt function. What it takes as input is the untidy data frame runners. We tell them what is the unique index, I think, ID vars.
Yes.
Yeah. And then ask it to pick what are actually values and should be represented in its own columns, value vars. And we give it a name for this, these values. These are distances. And whatever is inside also gets its own columns, its own column. Those are the time. So if you do that instead, what do you get? Like,
I need to repeat it so it actually prints it.
right.
You
So
get a sort of longish data frame.
right, exactly. So each are observation in its own rule. And it's very easy right now to compute something like speed, distance by time, and it gets fast and easy to do other statistics on top of it. Yeah, one more thing, like tidy data tends to be very long, like very tall. And if it's untidy, it has this side effect of becoming very wide.
So
So
you
sometimes,
could go back from the long format to the short wide format. I think it's called pivot.
yeah, it is called
Um,
pivot, and I think there there is example of that later on, or in one of the exercises, I think.
mhm,
Take a look at that.
yes.
Another thing that you want to do is to, sorry,
To get data from different data sources, right? Like,
exactly, yeah. So then suppose you were reading part of the data is in a CSV file, part of it is in a JSON or a Excel spreadsheet, then you can use pandas. But then what you get is you get different data frame objects, and then they are supposed to be together for your analysis. What would you do then? Like, the one way to illustrate is to by example. So here,
yeah, so you can create manually data frames, NumPy
mm,
data or something else, but you can also have a different set of data frames or have various data frames that have something in common. Like for example, here is the runner column,
mm,
and then you can do what's called merging.
right.
Um,
Before you merge it, can you print the age data frame so we know how it looks like?
yep, yeah. If I
Yeah.
may manage to type it correctly.
Or then I think you need a print function. If it's in the middle,
Mm,
yeah, it should be okay. It's a very small one.
yes.
Right.
So
So
let's see what happens.
mm, so we are creating a small data which should be merged into the previous data frame. Uh, so some observations on what the ages are.
Mhm.
And
And
so
I
as you
forgot
see
to assign.
here, yeah, that's a good observation as well. Like when you call such operations, they don't change what the original data set is unless you pass it back.
Yes. So if I do it now, there is a new column age, and it has for each of the runner rows in the first data frame, it has added the correct age from the second data frame.
Right. And that it knows through the on argument in merge.
Yes.
Uh,
You
s-
you can actually specify different columns if they have different names, but you know they are the same data essentially.
exactly.
You can specify different names in they're called right and left data frames in pandas.
Mm,
Bit like a database. So you can specify different columns.
right.
But here we were lucky that it was
Mm,
called runner in both of them. And a lot of the time it is. I mean, it's the same data, right?
right.
Right.
Then what else is there? Like there are of
Mm,
course other methods to combine things. For example, there is this concat data frame, but for concat to work, you need the data frames to be of the same size, I think. Uh, so, so in this, we'll not look at this example in the interest of time, but
yes.
it exists. Um, so as I said before, a lot of this is inspired from SQL. So SQL also has this concept of merging, joins, right join, left join, all that, and also
Yes.
to make selection based on some condition. And group by we have already seen. We saw previously group by based on just one column name, but you can also group by based on multiple column names, as shown below.
Do we want to run this?
Right. Yeah, we can
Let's,
take a look
let's
at
try it.
that. Some other ways to manipulate data.
So we're looking at the grouping by the gender of the person and whether it's we need to first include this child column.
Oh yeah, sorry, I skipped that. So you cannot
Yes.
use
So
the Boolean index to create new columns of your own. That's also possible.
yeah. So we are creating a new column named child that it includes all the people that's true for all the people whose age is below 12, and then we can group by that column and compute the means.
Exactly. And then you see for the survived column for these two combinations, what was the average split into gender as well. So you get two levels of grouping. It's grouped in the first grouping is based on male and female. And the next grouping is based on if they're a child or not. So you can do that too.
And what we can conclude from this, I think, is that indeed the women and children were sent first and will survive. More of them survived, much more of them survived than the male.
Yes, right. Women and children first to go there. So they actually followed through. That was nice. So now I think we have room to do some repetition on this exercise. In this exercise, you will be looking at the same Titanic data frame, and you're asked to compute family sizes based on a particular SIB SP column. It stands for the family size. And then there are other questions, and there is an advanced question as well. So we'll give you another 10 minutes to do this exercise, and we'll come back after that. So
Actually,
right,
maybe after this, right after this exercise, it would be good to take a little bit of a break. So we will
right.
reconvene at, it's not 2 o'clock.
15 minutes past.
15 minutes past sounds good.
Yeah.
So try to give the exercise 5 to 10 minutes. If you
Yeah.
get stuck, don't worry about it.
Don't forget to take a break too. Yeah.
And yeah, don't forget to take a break. We'll be back at 15 past.
Hmm.
Okay, so
Yeah.
bye for now.
Bye. I think it's time.
Yep, I
Hmm.
think we should be
Yeah,
back.
live.
Okay, and we are back with looking at pandas. And well, so we've seen what a pandas data frame is and how to handle it, and we've seen that pandas does everything in a series objects, but it can also do special things if you, because a lot of data is actually dates, right? It's when something happened, how old someone is. So pandas has special logic for handling dates, because there's if if you ever try to read in dates manually from different sources, potentially from different countries, you will know that it becomes a nightmare. But luckily for us, pandas has ways to understand the data, and we will explore that a bit with a new data set, the that is about the Nobel Prize winners. And yeah, there's a bit of special things you have to do to get the data actually, but we have it's because you cannot load it from the original source. So we also have put it on GitHub if you want to access it from there, or you can just download it yourself from the Nobel Committee, and work with it there. And if you want to, yeah,
Shall we take a look at how it looks like?
yeah, have you got it on your
I guess so.
machine
I
there?
have it kind of prepared. So let's see. So it has it's a data frame containing the names of Nobel laureates, when they were born and then they died, and when even the day when they actually got the Nobel Prize. So there are a couple of columns which deals with dates.
Yes. So maybe if we were interested in specifically these dates, it won't necessarily read them in as dates automatically if you just read it in from CSV, because there is a bit of computing involved, and if you don't really need it as a date, there's no point in doing that. So you have to tell pandas that it actually is a date. You can do that by using the toDateTime function. So
Right.
if you, yeah, exactly these. So if you run these, it will reassign the born, died, and year columns as a date. Can you actually run these and then look at the info again?
At the info? Yeah.
Or the D type for the born column?
Yeah. I did it all. I think it was easier. So you see, before it was object, and year was assumed to be an integer, but now it was reassigned as datetime. NumPy datetime 64
Yes.
data types.
So now we told pandas that it is actually a date, and then we can do through this .dt, we can get different parts of the date. So maybe you can run the what we see, like the dt.day and year and weekday, to see what. So we will get the days for
Right.
when they were born.
Some not a number.
Some are
If
not a
it's
number. For some the format might not have been recognized. For some, it might have also been missing in the first place.
could be an
Um,
organization, so there was no birth.
maybe.
Yeah.
We don't know that without looking
Mm.
at the data, but I don't think we have the time for that now.
No. No.
And then do we want to try to compute how long they lived, all these Nobel Prize winners? Maybe. So
Yeah. So I think for that we use the died column and the born column, get a difference, compute the days.
yes, get the difference between the days they died and the days they were born. We're using days because if we used years, I mean, we could do that, but it would be very, very inexact because the year is just the year number. And this way, if we use the day and then divide by 365, that will give us a much more exact time length.
Also, I think in this data set, the year is the Nobel Prize when they were awarded the Nobel Prize. So that's another analysis, I think.
No, but if you get the Nobel died minus Nobel born dot dt dot year,
right,
that
like that
would work, but it would give you potentially ages that are half a year off or
will be inexact. Got it.
be very, very inexact. So the days and then dividing by 365 is exact enough, I guess, at least for our purposes here.
So here we build that as a column into this, plot the histogram.
And then we can plot it as a histogram. And how are they? Well,
they live a happy life in the 80s, so it's not too bad.
Most of them.
Yeah. We can also do other kind of plotting, combining two columns. So we do a simplified span divided, grouped across subjects or category, as it's called here.
Yeah.
Yeah, nothing to see here.
Well, it works the same as with the data with a normal data frame. It's just that handling dates is quite a pain if you're doing it manually. So having this facility of pandas is really, really, really helpful. If you ever have the honor and joy to work with dates.
Exactly.
Right. But since it is already 23 past and the next topic will start at 1/2 past, I think it would be good if we maybe quickly discuss the third exercise, but didn't actually. You can do the exercise, of course, on your own time later if you want to, but maybe we can just show what it would be.
Yeah. So I have it prepared as a demo, at least for the first 3 we will show, and we can explore the rest later.
Yes.
So here the first question is, given this data set, which I have loaded here, Nobel, what will be the, which country has received the most? And to that, we use the column, which is called born country code. And we use the describe function, which gives you, along with the list of how many data entries are there, we also see how many unique countries, but also the top appearing country, which is US. So we see that the US has received the most number of Nobel Prizes so far. And here is some presentation on using the histogram. So here we create a histogram based on when they were awarded the Nobel prizes, at what age they were awarded. So to do that, we combine the Nobel born and year columns. We ensure that those are daytime types. We take a difference of these two, do exactly the same as before to compute the lifespan, but here it's the age. So we see that most of them got their Nobel Prize once they were close to retirement at the age of 60, I suppose. And you can also list Nobel laureates from your own country. I chose Sweden because I live here. But so what we are doing here is there's country column, can do a Boolean mask based on equality. And you can do other indexing after this mask is done. So let's check for Finland. I think it's correct, or is it just one? Maybe so, at least according to the data set. There are other advanced steps which you can follow through. The code is given here, but we leave that as an exercise later. And you can also do some fancy visualization on your own time. With that, there is some extra knowledge that you can do if you feel that Pandas is becoming slow while doing some operations. There is a numexpr optional dependency, optional library, which evaluates certain operations as strings instead. If you pass them as strings, they will give you back exactly the same result, but it'll be faster. You can also do custom creation of columns. We saw like with Boolean indexes, we can create columns, but if you want something really fancy, there is a pandas.apply. So you choose your inputs, you give pass a function which accepts one element at a time and then gives back another column by using this apply method. There are much more that you can explore. There are some tips for extra reading here. And also in the notes that we saw some discussion, like some people were asking about polars. So yes, polars is a rewrite of this approach basing everything that they work with from a library called Apache Arrow. Whereas Pandas was originally designed on top of NumPy. Although like Pandas recently has added some support for some support for PyArrow. It's very limited because they wanted to keep compatibility. So unless you're very careful, you usually end up getting NumPy as the working engine in Pandas. Whereas in Polars, it ends up getting really fast because it's has other properties, including being written in using Arrow. There are other libraries also, if it's very large data that you're using with. Dask is one such example, so which parallelizes such analysis on top of data frames. YX is also another library which is very similar to Pandas, written in C++, I think. Do you want to round up things, Susa?
No, I think that's as much as we have time for now. There's, of course, lots and lots of topics we could discuss about pandas. But there's a few other very interesting things that you're going to learn in this course, and let's give those people the time they deserve as well. So next up will be a lesson on X-array. If I am not entirely wrong, That will be by Marijn van Vliet again and Thomas Pfau. Do we actually have these people on stream already?
Hello.
Hello.
Right. So
Then we hand
we'll
over to you guys.
hand over to you guys and see you all at another time.
This is slightly better. Oh man, it's already getting dark. What's wrong with Finland? Hello, everyone. And welcome, Thomas. Welcome for
Hi.
joining us here and exploring X-ray. I was reading during the panelist lesson. I was reading the shared document a little bit, and it was one user who sort of desperately asked, like, wait, we have NumPy, we have normal lists, we have data frames. Now we're going to teach you about X-ray, and later on we're going to see even more packages. Like, how do I make sense of this? When do I use what? And I think this might be a good place to start here about X-ray. So these packages are created for people who are like using NumPy. That's the sort of the default. So first learn how to use NumPy and get comfortable in that. But then there were people who were using that for years, and for their specific use case, they were thinking like, okay, but what if NumPy could be even better? I have data that has many different dimensions, and I have rows and columns and fourth dimension and fifth dimensions, and I keep losing track of all of that. What if we could make it even better? And then they created X-ray.
And I'm pretty sure a very much driving factor of this is also having this small tiny bit that's annoying every time you're using it and that you just want to not have to use. So yeah, I want to find something how my specific problem can be solved better.
Yes, exactly. So for people getting confused, I would say, like, first learn how NumPy works. But then when you're comfortable with NumPy and you're asking yourself, wait, is there a better way? Then your answer is yes. And then we start talking about things like pandas and things like X-array. So let's get into it. What is X-array? Or what do you want to say?
I just wanted to check that. You always at the same time have to keep in mind that for its purposes, NumPy is really good. It's just that it's designed for a certain target, and in a lot of cases, different scientific fields have slightly different requirements to how they need to handle the data and how they want to manipulate the data. And that's why all of these additional packages arrive, and why people essentially design these additional packages. Most of them are somewhat solving one particular problem or aiming at it from a specific perspective of a field of research.
Yeah, for example, X-ray was created, I think, by people doing climate science, and it's very well suited for that. Although also in other fields, I think will be useful across other fields as well. But it was originally created by climate scientists to help their analysis. So what is X-ray? Let's get into it. So the problem that X-ray solves is that what if you have a NumPy array, but it has 3, 4, 5, 6 dimensions to it? If you start doing operations and saying, well, like give me the mean value across the third dimension, that is quite unintuitive. What is the third dimension? You have to look up, like, what are my dimensions? And so they developed X-ray as a way to give names to the various dimensions, the rows, the columns of a NumPy array. So we're going to start naming the dimensions. We're going to start naming all the rows and naming all the columns. We're going to assign units to it. So if something is in terms of location, then like, is this in meters or kilometers, or that we're gonna take a look at.
Or degrees.
Or degrees. So just to give an example, say we have a NumPy array, and we have a three-dimensional one, and that NumPy array, it contains temperature. This is temperature data. We're gonna record temperature at different locations across the Earth, and also at different heights. If you take a look at the entire atmosphere, you have an X and a Y coordinate, but you also have height. So it's going to be a three-dimensional matrix, and recording all these temperatures. And if we now have questions like, okay, can you, Thomas, now give me the temperature at kilometer 50, 50 kilometers to the right, 100 kilometers straight ahead, and then 50 meters straight up. You would
I
not
have no idea. Wait. Let me check the definitions that we have put in there, because I can't remember them.
Yeah, like which row, which column, right, do you need? So
Oh.
enter X-array. We're gonna name everything. In order to do this, let's actually load some real climate data. It's a good example for this half an hour that we have. Let's work on this. Let's work on temperature data. And in the lesson materials, we have a nice example data set that we can just load in, and we can see X-array in action. All right. So yeah, we're gonna use it. Data set. Oh yeah, you can ignore that warning.
Yeah, true.
It's some recent change in how the package resources package wants things. We can save it.
We are fetching this data set,
yeah,
and let's see. That essentially tells us now that we have this at a certain file path. So yeah.
We quickly use this PFIA dataset package just to download the data. Right? We could have like went to the website and downloaded from there, but this was just a quick way to do it for this particular dataset. But now we have it on Thomas's hard drive, and Thomas can load it. It is
and let's see what we have in there.
So a lot we have in there, and we have to go through it a little bit. What this file contains, I already told you it contains temperature data, which we'll look at, but it contains other things as well. But if we go from top to bottom, we see what we have here is an X-array data set. And an X-array data set is actually a collection of multiple NumPy arrays that all describe, in this case, the same piece of the Earth, but they're all related to each other. They describe the same thing. And in the data set, we have different coordinates. These coordinates are essentially the axes, the different axes or the different dimensions of our NumPy arrays. You can see most of our NumPy arrays will be four-dimensional arrays. And these coordinates, they specify what each of those four dimensions mean. So we have actually gonna like this custom bottom to top because it's more intuitive. We have the X and Y position on the Earth, where we're gonna have the temperature. We have the isobaric pressure, which is like the way that climate scientists like to indicate height. So they indicate height not in meters, but in like pressure, well, isobaric pressure of the air. That's, I guess, more intuitive to them. And in addition to that, temperature changes over time. So we also have a time dimension. So we have recordings there across time even. So a four-dimensional data arrays we have.
Even though I think we just have one time point, if I see
We only
that
have
right.
one time point, yes. So
But we could have multiple time points here as well.
Yes, with this example data, it's been cropped. So the original data set had thousands of time points. We cropped it down to only one time point to fit into our puny memory. But yeah. But the dimension is still there. Okay. Now I said that an X-array data set contains multiple NumPy arrays. So we don't have a single one, we actually have multiple ones. And those are the data variables. So the most intuitive one here is, again, I go from bottom to top. The temperature one is like the last data variable there in the data set. So the temperature contains, it's a 4-dimensional array. You can see it where the first dimension is time, the second dimension is the isobaric pressure, third dimension is the y location, and fourth dimension is the x location. Right? And it contains the temperature. But we have other arrays as well. We have one for the v component of the wind. We have one for the u component of the wind. We have the geopotential. I don't even know what it is because I'm not a climate scientist. I don't even know what it is. These are all things that are 4-dimensional arrays. I can see from there, and they have 4 dimensions defined. Now, in addition to that, we have 2 NumPy arrays which are 2-dimensional. So that's the latitude and the longitude values of at the x and y positions in this data set. So they're only 2-dimensional, but the dimensions correspond to the x and the y dimensions of these larger 4-dimensional arrays. So I'm still following, Thomas. So we have different arrays.
It's essentially you have multiple different types of data in the same data set, and for example, they decided they don't want to have the latitude and longitude as their own variables or coordinates, but they want to keep this information alongside so that you don't need to recalculate it whenever you actually want to see where am I actually, because as you can see here, the x and y, they have minus and plus.
Yeah, there are lots of kilometers, like in a nice square grid.
What's the 0 point?
Yes.
You wouldn't, without having this latitude longitude information, you wouldn't have the 0 point.
Yeah.
So you wouldn't know where this actually is.
Yeah. So we want all this data together. So X-array is really, it's a convenience thing, right? We could have these as separate NumPy arrays and just loaded them one by one. We could. But with X-array, we can just have them all in one like data set object. And as a data set, it's really powerful. We can slice up this data in such a way that all the arrays get sliced in exactly the same way all at once. So if we visualize this at one time point, so if we now like discuss only one time point, our data is 3-dimensional. We have x and y and the height and the temperature there. So now by specifying these dimensions in the data set, so we don't longer have to talk about the first dimension or the second dimension. We can talk about the x dimension and the y dimension. Okay, that's not really much better, is it? But we could talk about like the isobaric pressure dimension. We can talk about the time dimension. Dimensions have names now. And then each row in each column, each item along that dimension, we can also give it like a label. So if we look about the x across the x dimension, it's not like row 1 and 2 and 3. We have actual, like in kilometers, we have one that is like 895 kilometers that way. And we have another that's 1,025 kilometers that way. Or if we go up, we could say, okay, we're going to up with like 100 units in hectopascal of isobaric pressure. So instead of just having abstract numbers, we're talking about concrete, real things now.
And you can also use these as kind of indices to these different dimensions.
Exactly, and that's how we're going to work with this data now. So in order to make things a little bit easier for us, let's just focus on the temperature variable now. So let's see from this data set, Thomas, can you just pull out the temperature data?
Yep.
So in a way, this is a little bit like similar as what we saw in pandas, right? Yeah. We have these different variables in there, and we can pull out a variable by indexing our data set this way, as if it was a Python dictionary.
So we can essentially extract this data variable here.
Yes.
And that's where we get this information from.
Yeah. Yeah, the DS is our entire data set. We're now just going to grab the temperature data from it. So now it's a bit more manageable. It's just a single variable now. It's no longer an entire data set, single variable. It still has our 4 dimensions, right? And
it still has quite a lot of different attributes.
Yeah.
like this.
There's also attributes. Yeah, I haven't talked about. So attributes are just like freestyle annotations to the data. They're key values. So just annotations to say, well,
what's the actual unit of this piece of information?
Yeah.
What temperature are we looking at?
Exactly. And these are like you can you can define your own attributes. So these attributes are completely defined by the people who collected this data, just to annotate it, and they can put in there whatever they wanted. And it's really helpful. So now we just don't only have the numbers, we have like a lot of description about what this data is, what it represents, and it's all in one file. So it's very convenient.
That was the wrong thing.
Okay.
Wanted to take the just script a bit to the side so that we can see what we are actually using here as well, so that we can stay in sync with the. But yeah,
now
if we want to get to the actual data,
if you actually want to get actual data back, it's just as in pandas, it's dot values. So you see that these packages look at each other. What are they doing? So in pandas, if you want to roll NumPy array, it's dot values, and then an X-ray say, okay, let's do the same thing. Overwriting things, Thomas. We still need.
No.
Oh no, it's in. No, you're not. Okay, sorry.
No, it's not overwritten.
What you're doing. You know what you're doing. Yeah, now we have a plain NumPy array, so you can always get it out.
I'm not sure if I know what I'm doing, but I'm not overwriting it. Not yet.
Okay, so obviously
Hey.
now that we have given names to all our dimensions. So if you now want the data at a certain X location, for example, can you give me the temperature, and I want the X location of minus the certain value 3,292. I want it as a specific location. So you can say, okay, I want the temperature, and you can use this dot cell method now. Let's select some data, and we can say, okay, the X should be this value.
Just noticing something here. What would actually happen if we take the value here and not the string?
Oh yeah, well you can. I think that should still work.
That should still work, and yeah, makes
that actually makes
more sense.
That is true. You should maybe update that in the thing. I agree. This makes more sense. But are you happy with that, Thomas?
Well, I'm not really happy, because if I look at this, I have no idea where this number actually comes from.
Yeah, it's really specific, right? It's a specific X location. It's kind of annoying, and we would like to indeed say, well, we want a location at like the X coordinate that's roughly 3,292, right? The fact that it's like,
yeah,
but that's not the specific like row in our data. That's not how we called it. We called it 002. But so this is where we have we can tell X-ray, well, just give me the closest row, right? Just the nearest.
And that is quite powerful, because that allows you to essentially, we have essentially what we had before, we have it back, and this allows you to just take whatever index, essentially, as long as it's a numeric dimension, and go to the closest thing and find things that are closest to this location, which, that's quite convenient.
Yeah, if things are overly specific, like our X and Y coordinates, right? So yeah, that's a useful thing. Of course, I mean, we should maybe quickly show that of course you still can index your data with integer indexes, right? And then again, they borrow a convention from pandas. So we're now showing you cell for select, but we also have iCell for
index
select. So now X is no longer like it's 1 or 0 or like, so this would be the second value along the X dimension, for example. So that is which is some number.
Something else, and which is admittedly This is the kind of thing where you very often get typos that lead to problems. Because you select, well, cell close enough, and given that you can just give the same dimension name, that can lead to inconveniences.
Yeah. So but in many ways, these X-array things, they behave like NumPy arrays. They're just a little bit more convenient. So, for example, Thomas, can you just give us the average temperature, like for this entire data set?
Yep.
So that would be the temperature, average, mean, right? Just like you would do in now, without, if you just do mean, like you will get the average temperature across the entire thing, right? Okay, but yeah, now I want the mean along a certain dimension. So I want the mean, but I want the mean at each isobaric pressure. So each height across the atmosphere. So in NumPy, I would have to do, well, that's the mean along the second dimension, I think it was. But with X-array, we can name the dimension by its name. So
that was isobaric 1,
yeah.
Which we had here as this coordinate.
Yeah. And that just reads a lot nicer in your code. It's much more obvious what you're doing, that we're taking the mean along the isobaric dimension.
It makes the code a lot more understandable. You don't have a number in there, and well, what people often do with NumPy or similar things, you define a variable that is called isobaric equals 1 or something like that to fix the dimension, so that you can write code that is still understandable. Because if this is, let's say, if this would be 2 1, you have no idea what this means.
No.
That's pretty much useless code, or extremely not useless, but very, very difficult to debug code.
It can be, unless you commented it properly. So if you do this in NumPy, you definitely can. But then you need to comment it and explain, like, this is this dimension, and we're doing this, and it's absolutely fine. But if you want, like, X-array, this makes it a little bit more convenient.
Or you could, or as I mentioned, you can just say isobaric equals 1, temperature equals 2 or something, and just use then these variables instead of the actual values.
Oh yeah, that you can also definitely do. Yeah, that's a useful.
Would be what I would be doing if I would want to use NumPy for that, something like this.
Another way where this is really convenient is when we want to plot the data. So for example, let's make a plot again of the temperature. And let's see, how do we do it in example? So I want to plot, but I want it at one of the x coordinates, and I would just want to look. Give me the height and the temperature. Let's see how the temperature changes as we go further up in the atmosphere.
So that would be select.
Yeah, so the select, maybe now we don't really care about which x it is. Just give me the third, the third row along the x dimension.
Okay.
So that's ISL. So at this moment, I don't care. So we can just, do plot. And will give us a surprisingly detailed plot. Because we've named all the dimensions, and we also gave them the coordinates along all the dimensions. If we just plot something, look at how much information X-array can already annotate in the plot. So we see here the temperature at different y positions, which are in kilometers. We have the height there now in terms of isobaric surface pressure, which is again in hectopascals. And we have the temperature there in Kelvin.
Essentially, we see a slice going, I would assume north to south, no, east to west, and to the top.
I think north to south.
North to south? Was X
is y,
east
yeah.
to west? Yeah.
Yeah, you would think bottom to top, but no. Pressure increases when we get closer to the Earth.
Yeah, true.
Because X-ray is not psychic, so it doesn't know that. So ideally, we would plot this isobaric surface dimension. We would flip it, which we can quickly do. I mean, if you know matplotlib commands. So this plot function, it also takes matplotlib keywords. So can you give it y increase as one thing, y increase, and then set it to false is equals false. So with a capital F, yeah. So the y thing in our plot should not be increased, should be decreased. Okay, so then it flip, but it's a matplotlib thing, just to show that works. So now it's more intuitive. We see higher temperatures at the ground, and then as we go higher up, things gets colder. Yeah.
Definitely.
Okay. So that's the
3D kind of view of things.
Yeah.
You could also just look at, well, one specific point on the map.
Yeah, we can do, but we actually don't have time for that because we only have 5 minutes left.
Oh, yeah.
We're gonna skip ahead. We're gonna skip ahead to creating our own X-ray data set. So now we loaded one from the file that somebody else has created. So what if you have a bunch of NumPy arrays yourself and you want to put that into an X-ray data set? So if you look a little bit at the code, I would highly recommend we just copy paste this, Thomas, because it's a bit verbose, because we have to tell X-array all these things. So we have our NumPy arrays. Say we have pressure data and humidity data. This is how you put it together. So we need for each of our dimensions, we need a label for that. So now we have time and location. But then for the time dimension, we need to specify, okay, what time, right? It's not time 0, 1, 2, 3. No, it's in actual dates. And if we have location, what are these locations, right? So now in this example, we named them somewhat unhelpfully, location 1, 2, 3. Maybe this could be like Helsinki, Oslo, Helsinki,
Stockholm.
Oslo, Stockholm. Yeah, otherwise they feel left out. Yeah, right. You could give them meaningful things. Yeah. So yeah. So we have two arrays, different coordinates, right? We can give it some attributes, right? Give it a nice description. This is weather data, and the author, we are like data scientist, a real data scientist created this, whatever we want. And we have a really nice like X-ray dataset object that contains a lot of information. And once we have that, maybe show them how to save it. Do we do that? That would be nice. Maybe to enter some. So with X-array, one of the best ways to save this is into a file format called netcdf. So netcdf is created for to contain this sort of data where you have multiple NumPy arrays and they describe the same piece of land of the same object. It's a really nice data format to save it to. And this is also sort of the default in X-array. In X-array, you're sort of expected to save the data in this netcdf format and load from it. All right.
And you can then essentially do something like this to get the data in Helsinki for pressure.
Yes, exactly, Thomas.
Which is, some random numbers, so don't worry too much, but
you can get it. So that's our quick, like super quick overview of X-array. The main takeaway is you can give like names to your dimensions and names to all the rows and the columns, and then you can use them to make your code a bit more readable if you need. All right.
Thank you so much. This was super interesting and there were relevant questions in the notes, but our time is out for today, so we can keep on answering to the questions in the notes later. If you can briefly switch to the notes view and scroll to the bottom, I've added a section for the feedback of the day. So it's like, again, just a simple type of feedback questionnaire so that you can mark with the O if it was too fast or too slow, or if the speed was good. This is very important because we can quickly adapt, for example, already for the next day, if this was too fast or too slow, and so on. And then it's important to mention, one good thing about today, but also something that could be improved. We are improving these courses every year. I think this is maybe the 4th time that we're running this, or 5th. I don't know. I lost the count. But so, what you see is the improvement of thousands of comments from previous runs and previous learners. All right. Do you have any final words to mention, Maran or Thomas? Anything else?
Go take a break. Do not become overwhelmed. we were throwing a lot of stuff at you this 3 days, so it will take a while to sink in and go back.
There are so many packages things in general. I think what we want to provide you is mainly an overview of what's around, what you can use, and probably whatever you will use, you will have to read a bit more in the documentations, because your specific problem will be very special, and we just want to give you hints as to where to start looking and give you a couple of general basic ideas, because all of this is very on the surface of the things, and rarely goes into extreme low details, because those low details are, in my experience at least, always very, very project specific, and would probably be useless to 90% of the other people that are here. So yeah, we just want to give you a general overview of what is around, what you can use, how you can approach things.
Yeah, and in general, if something was too fast, as soon as the streaming stops, the video will be there, immediately available on the same TwitchTV page, and later we will upload them to our YouTube channels. All right, but thanks a lot for all the listeners and watchers and people online, and for the great instructors for today. We meet again tomorrow morning at 10 a.m. Finnish time, 9 a.m. Central European time. Until then, bye bye.
See you then.
See you.